Hello and welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. And this is part two of a two-part video about compound interest. In our last video, we had actually done this exact problem that I have here. If I invest $500 in an account earning 3% interest compounded annually, what will my investment be worth? In fact, if you'll indulge me here are notes from last time, and we did all the work using the formulas. Okay, and I think it's an important skill to be able to do the formulas, but it's also important to know where we are in history and things that we can do. So I'm going to clear my calculator here, and here's an app that or a function that you're going to want to be able to use in the calculator. You'll see the apps button. I just highlighted it in red, apps, and then you'll see a menu that says Finance, Cabri Junior, Cell Sheet. There's a whole bunch of apps built into the graphing calculator that quite honestly I hardly ever use myself. But the first one is Finance. So we're going to select Finance. And then number one is a TVM solver. TVM stands for time value money. Now you'll notice that the calculator is going to ask for certain information. N, it's capital N, not a lowercase n. I%, PV, payment, FV, P/Y, and C/Y. So let me talk about those. Again, our formula that we've been working with, A equals P times 1 plus R over N to the NT. I've also told you that in finance, we'll often use FV instead of future value, instead of A, the amount in the future. And as opposed to P, we use PV. And you'll notice that the calculator uses the PV as well as the FV. And then we have 1 plus R over N to the NT. Now the values that are here for the TVM solver match similarly, but not exactly. Okay, so I'm going to kind of go through these not in order. First of all, payment. This is going to be a future video. So for right now, we're going to leave payment 0. In our next couple of videos, we're going to talk about not just if I put $500 into an account and I let it sit there. I put $1,500 or $10,000 into an account and I let it sit there for 20 years. But we'll talk about what if every month I invest $50 into the account, or every month I invest $100 into the account. That's where my payment will come into play in a savings account. We'll also, in the next couple of videos, start looking at loans. If I borrow money for a car, what will my payment be? And that's where, again, we'll look at the payment. But for this video, it's going to be 0 because we're still going to invest money and let it sit there. PV is the present value. FV is the future value of the account. Okay? Now, at the bottom, we've got PY and CY. PY is payments per year, and CY is compounding periods. One of these days, I'll learn to write better. Compounding periods per year. Now, I want to show you in the calculator, please pay attention here, that my PY and CY are both currently set at 1. If I change PY to 12 and press enter, the CY automatically changes. Again, if my payments per year is 4, my compoundings per year switch to 4. There will be times when those don't need to match. Notice if I change my compoundings to 12, that the PY doesn't change. Okay, so since we're making payments of $0, in this case, I'm just going to change my CY by pressing enter at the PY. It just keeps them the same and it doesn't make any difference for now. In the next couple of videos, you'll see where there's a difference. Also, the payment, making payments $0, it doesn't matter. Typically, my interest is paid to me at the end of the month. I deposit money into my account at the end of the month. My payments are due on a loan at the end of the month. So for purpose of this course, it's going to stay on end. That's not going to change. So a couple things left to talk about. The I%. In the formula, okay, if my interest rate is 3% interest, R is 0.03, and I put 0.03 into the formula, okay? In the calculator, this you put in the percent as a percent. Okay, so 3% interest would be 3 or 5. Okay, so it's the interest rate. Then the capital N here is the NT. So this value here, the N, is the N times T. That whole thing equals N. Okay, so let's look at a problem. And I'm going to do these with the calculator. For those of you watching this video that are taking my Math 1500 course, on my tests, there's a couple where I make you do with the formula. For the bulk of the problems, I want you using the TBM solver. You're going to, in real life, whether you're going to business or finance, you're going to use a TBM solver. If you go and buy a car, you're going to use a TBM solver. If you're doing any calculations, you're going to use the solver. So in this course, I'm going to really push using the TBM solver. So if I invest $500 into an account earning 3% interest, my present value is $500. My interest rate is 0.03, so my I percent is 3. Interest is compounded annually, so PY and CY both equal 1. How much will my account be worth in 10 years? Okay, so I'm going to invest $500. So my present value is $500. My interest rate is 3%. I want to make sure that my PY and CY are both 1 since my interest is compounded annually. What's the future value going to be? Payment I already talked about. We're going to leave that 0 throughout this entire video. So now N, annually, for 10 years. So my question is, what's my future value? I go to FV and I press alpha, enter. Notice that above the enter bar, above the enter button, it says solve in green. So I do alpha solve. And there's $671.96. Now let's talk a little bit about that negative value. The TBM solver is programmed to think your present value is positive. You invested $500 into an account. The account's only there for 10 years. And at the end of the 10 years, you took that money out of the account. So that negative is directional. So the account's not going to be worth negative $671. It's going to be worth $671.96. It's just that you're going to withdraw that. Now let's check the notes from the last video. Notice for the same problem, we had $671.96. Okay. In 20 years, my N is now 1 times 20. I'm going to go back to my FV, alpha solve, and after 20 years, my account will now be worth $903.06. Suppose I need my account to be worth $1,000 in 15 years. What interest rate would I need to earn? Well, I invested $500. I don't know the interest rate. That I'm going to have to solve, and I want this to be there for 15 years. Now, the thing is, what's my future value going to be? I'm not going to put in 1,000. Remember, my 500 and my present value is positive because I put $500 into the account. In 15 years, I want to be taking $1,000 out of the account, so it's negative $1,000 because it's coming out. What interest rate? Alpha solve. The interest rate I'm going to need is 4.7%. Okay, we can check our notes again from last time. Same problem, but with all this math in the formula, but we still got the 4.7%. D and E. Okay, again, the notes from last time, we had to use logarithms to solve for t to see how long things will take. Let's try this with the TBM solver. If the best interest rate I can find is 3% interest, how long will it take? I set my interest rate to 3%. Everything else stays the same. I'm investing $500. It's compounded annually once per year. I want to withdraw $1,000 from my account. how long will it take? I simply go up to the n, alpha, solve. It will take 23.4 years. If the best interest rate I can find is the 3% interest rate, how long will it take for my account to be worth $1,600? Well, this time, instead of withdrawing $1,000, I want to withdraw $1,600, and I want to go back up and find out, alpha solve, how long that will take. That will take 39.4 years. The TVM solver makes things much more simple. However, test scenario, show your work scenario. If you don't show your work, a right answer is right and a wrong answer is wrong. So I would encourage you, for test purposes, again, if you're taking a test with me and you're using the TVM solver, that you put n equals, I equals, and you tell me what you put in for the values. Okay, so you got 3%, okay, and your PV is 500, and again, you complete all of that. If you put that in, then I know what you entered. Otherwise, a right answer is right and a wrong answer is wrong. Let's move forward. We also did this problem in the previous video, the difference being that the interest is compounded monthly. The only difference really that I wind up making in the TVM solver is to accommodate for the monthly, I want my CY to be 12. PY is also 12, just because that doesn't matter, so my compounding is 12. So now I'm going to invest, notice I'm going to invest $1,500 into an account earning 6% interest. So my interest is 6%, compounded monthly, so my CY is 12. How much will my account be worth in 10 years? Now here, this capital N is not going to be N. It's not going to be 10, I'm sorry. Because it's going to be earning interest monthly for 10 years. So that's 120 months. Now you notice I said for 10 years, 12 times per year. I can do 12 times 10 and the calculator will do that calculation for me. How much will my account be worth in the 10 years? FV, alpha solve. It's going to be worth 27, 29, 10 $. After 20 years, now that's going to be 12 months per year for 20 years, or 240 months. Alpha solve, my future value is 49.6531. If you watched the previous video, again, you noticed, took us a little bit more work to get to those numbers. How much would the account be worth in 20 years if the interest is compounded quarterly instead of monthly? Now, the first thing I'm going to need to do is change my PY and CY to 4. CY is 4 because we're compounding the interest quarterly, which is 4 times per year. Payment's still 0. We still invested $1,500 into the interest paying 6%. But now this is going to be 4 quarters per year for 20 years. And so my future value, alpha solve, is going to be 49.3599. How long for the account to be worth $5,000? So notice it's going to be very similar in time. But after the number of months, I'm going to want to withdraw $5,000 from the account. I invested $1,500. Interest is paid quarterly. That interest is 6%. Now the thing though here, I'm going to solve for n, how long it will take me. Now notice I have 80.865, but that's not years, because remember our compounding is 4 times per year, quarters. So that's 80.86 quarters. I need to divide that by 4 to find the number of months. So if I divide that by, number of years, that would divided by 4, that would be 20.2 years. Okay. Suppose I want my account to be worth $3,000 in 10 years. What interest rate would I need to earn? So I want my account to be worth $3,000. I'm going to want to be able to withdraw $3,000. When we just want to find interest rate, we're okay talking about annual interest. Okay, I'm going to actually make them both one. I'm investing $1,500. I made my CY 1, so we're going to assume this is 10 years. Alpha solve on the interest rate. I would need to get 7.18% interest. Okay, the TBM solver makes things easy. I know all the pieces of information except for one. Okay. Here's a different question I didn't ask last time. The best interest rate I can find for my account is 6%. So let's put that back to 6%. Compounded monthly. So let's put our compoundings back to monthly. However, I need my account to be worth $3,000 in 10 years. Whoops, times 10. So that's 12 months times 10 years is 120 months. To accomplish this goal, what would my initial investment have had to have been? So alpha solve on the present value, I would have needed to invest $1,648.90. If I did that at 6% interest compounded monthly, my investment will be worth $3,000 in 10 years. Okay, so there's another look at investment problems, compound interest problems, and then being solved with the TBM solver, which is a much more powerful tool than just having to use the formula every time. I want to now look at a couple of different types of word problems that we can look at, right? The Megabucks Corporation is issuing a 10-year corporate bond paying no interest during their lifetime, but they promise to pay the maturity value at the end of the 10 years. Okay? So they're saying that they don't pay interest during the lifetime, but at the end. So if at the end of 10 years you cash it in, okay, the return is 6.5% interest. Now the maturity value is $10,000. So that means at the end of the investment, it's going to be worth $10,000. It's like taking $10,000 out of an account, earning 6.5% interest compounded annually. I hope you're seeing the changes in the calculator as I read the problem. Okay. If it's a 10-year bond, it will take 10 years to mature. That means the present value of that bond would need to be $5,327.26. What I know about this is that if I pay more than the $53.27 for a bond that takes 10 years to mature, I'm earning less than 6.5% interest. If I pay less for that bond, I'm earning more than 6.5% interest. So if I'm going to go buy bonds, say, for my kids saving for college, I'm going to target about a $5,000 investment bond to be worth $10,000 in 10 years, and I'll be earning 6.5% interest approximately. Okay. Now, a lot of things can be looked at using the TBM solver, even though it may not seem like an investment. Inflation in Jensen land, yes, it's a mysterious place, is currently 5% per year. I'm considering buying a new television, but I'm also considering waiting, to make the purchase. If the television that you're considering currently costs $500, what would you expect to pay for that 2 years from now? I'm going to look at this as if the present value of the TV is $500 and it's increasing at 5% interest per year, annual interest, annual growth. What would that TV be worth 2 years from now? So my interest or my inflation rate is 5%. The value is currently $500. And we're going to say annual, so my CY stays 1. If I wait 2 years to buy that TV, what would the future value be? If I wait 2 years, that TV is going to cost $551.25. Let me write this down correctly. $551.25. Okay. Do I want to wait? Buy it now. Cost is going to go up. I want to consider that. Okay. Inflation in Jensen land, let's say, is still 5% per year. Which would be more expensive, to buy a car which costs $20,000 today, or a car which 3 years from now will cost $24,000? I think what I'm going to do is I'm just going to say, let's look at the present value of the car that's worth $20,000. If my growth rate, my inflation rate is 5% annually, what will that car be worth? What will that cost be in 3 years? Present value was $20,000. 3 years from now, at 5% interest, that $20,000 is $23,152. It would actually be cheaper to buy the car today than to wait 3 years and pay $24,000, if you can afford it today. Okay. You may have seen terms like APR and APY. APR is the annual percentage rate. APY is the annual percentage yield. Okay. So let's look at an example. Okay. I invest $1,500 into an account earning 4% interest compounded monthly. What will my investment be worth after 1 year? Okay, well, I'm going to go to my TVM solver and say I invest $1,500 earning 4% interest compounded monthly. After 1 year, which is 12 months, my investment is worth $1,561.11. So I earn $61.11. But what's my annual yield? To do that, I'm going to change this just a little bit. Suppose that I invest $100 at 4% interest compounded annually. How much interest will I earn? Well, $100 compounded annually for 1 year. You should be able to predict what my value is going to be. AlphaSolve would be $104. I earned $4 on 100. That's 4%. But what if I earn 4% interest compounded monthly? So my N would be 12. If I compound my interest 12 times a year, 1 year, 12 months, my N is 12. What's the future value of my account? At the end of that year, my investment is now worth $104.07. So that would be 4.07% yield. My APY is 4.07% interest. I didn't only earn 4% interest. I earned an extra 7 cents because that's interest on the previously earned interest during that month. So there's a little bit of a difference between APR and APY. Okay. So if we look at example 4, what's the difference between 6.5% compounded monthly or 6.7% compounded annually? Now the 6.7% compounded annually on $100, you're going to earn $6.70 in 1 year. But if I invest $100 at 6.5% interest compounded monthly, so my CY is still 12, and I do that for 1 year, so N is 12, notice the future value for my account is $106. This would be $106.70. That would be 6.7% APY. So even though my interest rate is 6.5%, my annual yield is 6.7% because of the monthly compounding. So actually, these two investments are worth the same. Okay, let's look at the last example here, where some people get into trouble with these. And I actually have a friend who used to do these, and I would tell him all the time, don't go with a payday loan. Some lenders will seek to exploit people in need of immediate cash. These are called a payday loan. My Cash Now, hopefully they've been shut down, but at the time I wrote these notes, they were still operating online. They're currently offering the following terms on a payday loan. I will loan you $500 for 2 weeks, 14 days, and I'll charge you a finance charge of $109.90. What's the annual percentage rate for the loan? Now, if I think about the function, I think about the formula, the PV is $500. The FV is $609.90 because the loaner is going to loan me $500 and I'm going to pay him back $609.90. He's investing $500 and getting $609.90 back. Okay. So my future value is $609.90 for a $500 investment, 1 plus R, and we're doing annual, so our N is 1, to the T. Now, how many years are we investing this? Well, that's 14 days. So my exponent here, my T, is going to be 14 over 365. I can do this with the formula. I can use my TVM solver. I'm going to choose to use the TVM solver. The present value of the investment is $500. The future value is $609.90. If I want to think about it, I'm going to be given $500, so that's positive. I'm going to return $609.90. We're talking about an annual rate, so my PY and CY should be 1. We want to figure out the interest rate. The N is 14 over 365. That's 14 days. Alpha solve to find the interest rate. That's not a typo. The interest rate is 17,669.2% interest. Okay? If you were to borrow from these people $100 for the entire year, you would owe $17,669. Okay, so this is really, really, really crazy stuff. But that's how the TVM solver works. That's how investments work. I hope that this has been helpful. As I've said multiple times, I want you on my test to demonstrate with 1 or 2 problems that you can use the formula. After that, TVM solver. And I will know you will be rewarded for having watched this video by your performance on the test with the TVM solver. Again, thank you for watching. If this is helpful, please remember to like or subscribe. And I will see you next time when we talk more about annuities and finance from the other side, borrowing money and having to repay it. Thank you.